Hi, everybody. I'd like to welcome you today to the second in our sessions of League of Legends workshops. Today, we're going to be doing Introduction to Neural Networks with Shri and Shal. If you have any questions today, please ask in the Q&A and we'll get back to you as soon as we can or answer them live. Without further ado, I hand over to Shri, who will take you through the session today. Over to you.
Yeah, thanks, Jane. Thank you so much. Just a brief introduction about ourselves. So I work as a product manager with the OCI Data Science. Primarily, I work on some of the data science efforts related to the model catalog and feature store and some of the other portfolios. So I come with 19 years of work experience, primarily working on industry verticals such as in semiconductor, manufacturing, print media, and as well as aerospace and aviation domains. So I have a master's degree from National University of Singapore and an MBA from University of North Carolina. Thank you. I'll just hand it over to Shale to do his introduction.
Hi all, my name is Shell and I'm working as senior member of technical staff in OCI Data Science. Currently, I'm leading efforts related to model catalog capabilities in OCI Data Science portfolio, especially related to machine learning engineering and MLOps, which includes data processing, feature engineering, experimentation, model design, model training, and optimization, along with model deployment. I'm having 7+ years of working experience, and I have worked with companies such as Amazon, Xilinx, and NVIDIA. I hold master degree from BITS Planning and bachelor degree from University of Pune. Thank you.
Thanks, Shil. So of the second labs, we would primarily go through, most of you would have got this link. If not, I think I'll just put it on the chat window here. So you might have registered for this particular session. So let's log in. So when you log in, you can go to the sign in option here. For me, it is the single sign-on option that enables here. Just a second, I think I should enable it through a VPN. So just give me a second, I think I'll just log in through the VPN and think it should be done. So once it's done, I'm just going to log in through a secured sign-on option. Sorry. I think I'll just go back, resubmit this. Sorry about this. I think it's one of these issues that I would face. So when you click on this, usually it should take you to the Apex Labs. And then once you go here, it should be able to let you in. So this is the window that you would generally see here. And once you go into the live labs, primarily we would search for the League of Legends, and we would select the second of the labs, which is Introduction to Neural Networks here, ID 3444. And let's click on it. And this is actually Introduction to Neural Networks. So in this lab, we would go through the following labs. One is provisioning the infrastructure, understanding the neural networks, and we will build a neural network with FastAI and TensorFlow. So in this workshop, actually, we would primarily focus on understanding the neural networks and some of the nuances or the terminologies within the neural networks. But we'll not be able to go in depth, but we will be pretty much hands-on in trying to build a neural network using FastAI Python package. So let's get started. So what you can do is if you click on the start button, you would see something called run on your tenancy. So let's click on run on your tenancy. So it'll take you to this lab steps. So first is the introduction. What this workshop will do is we'll actually build an offline model. That is actually, we would be taking the League of Legends, data, and then primarily we would compare how it actually, how the players performed when compared to the previous games. And then we will actually build a live client model as well, where we'll obtain a real-time data from a match and try to run it through a model, and then try to predict a win percentage or a probability of win between 0 and 100%. So when you click on expand all tasks, it actually goes through an introduction of League of Legends. So the League of Legends is a strategy game where there is a team of 5 members on each side, and then it's primarily there are 5 powerful champions, and they are trying to destroy each other's base. So there is you can choose about there are 140 champions across, and then there are these place secure kills, take down towers, and usually the battle your way through the victory. So if you go through this, there is a team composition. The team composition is generally 5 members on each side. And then we would capture those metrics or the data associated to each player. And then also we will try to predict a win probability against that. So when we look at it, let's go through a short, brief introductory video about the League of Legends game. Let me know if the video is running, and if you have any audio issues, please let me know. So let me just quickly run this.
Want to know what League of Legends is without having to read an article or watch a long video? Hey, I'm Nate. And today I'll be starting a new series called Explained in 3 Minutes, where I try to explain some gaming related topic in 3 minutes or less. Keeping this part short today, the like and sub buttons. If you enjoy the video, you know what they do. Let's roll the intro. Let's start off with some general concepts. The game is 5 players versus 5 players. Each player will choose a different character with different abilities and classes. First to destroy the enemy nexus wins. In this game, there are 3 kinds of structures. The first is the nexus. This is at the heart of each team's base. First team to destroy the enemy nexus wins. This is the main objective of the game. The nexus is protected by 2 turrets. Turrets are the second kind of structure. They attack enemies that go underneath them, and they give you gold and your team gold for destroying enemy turrets. Each lane has an outer turret, an inner turret, as well as an inhibitor turret. This brings us to our last kind of structure, inhibitors. When destroyed, they spawn super minions that have far greater health, defenses, and damage, as well as 70% reduced damage from turrets. They also increase the stats for other nearby minions. These guys can win games if ignored. The inhibitor will respawn after 5 minutes, which will stop the super minions from spawning until it is redestroyed. In this game, there are 3 lanes and 5 roles. First, there's top, which are typically your bruisers and tanks, which go to the top lane. You have middle, which are your mages and assassins. They go down the middle lane. And the bot lane, where you have high DPS marksmen and supports. Okay, those are the 3 lanes. Each lane will repeatedly spawn minions that give gold when you hit them with the killing attack. The last role is the jungler. The jungler can be any class, and they obtain golden XP through killing minion camps in the jungle. When they're not killing minion camps, they're surprise attacking and assisting lanes. As well on the map, there are the dragon and baron pits. There is one on each side of the map, and throughout the game they spawn large monsters that give big bonuses to the team that kills them. And lastly, for general concepts, we have items. Spend gold earned by killing minions and enemy champions to buy items that increase your stats. Each game you will buy different items based on what you need that game. Oh, and one more thing. Every game your champion level will start at level 1, and you can get up to the max level of 18, and your level resets every game. However, there are mastery points to show time spent with a champion, and progression outside of the game. Next, I will be going over what a game is typically like from start to finish. You start in the client. This is where you push the play button in the top corner, select your game mode. For this we'll be doing normal, but there are a couple other fun spin-offs you can choose from. You have the lobby, where you can invite your friends to play and select your role, and once all 10 players are found, you go into champion select. This is where you choose which champion you want to play, as well as your teammates choose which champions they play, and you can also choose summoner spells and masteries. These are a set list of interchangeable abilities all players can choose from. After this, you go into game. There are 2 phases of the game. Lane phase, which is typically before 15 minutes. In this phase, you will be dueling your opponent as well as killing minions to gain gold and buy items. After this, you have the group phase. This typically is after the 15-minute mark. There are various strategies for the group phase. Generally, your team will start grouping to fight the enemy, as well as destroy and take objectives as a team. The game ends when the enemy nexus is destroyed. So what do you think of the video? Let me know in the comments below. Hit the like button.
Yeah, so that's the introduction about the game. So in order, let's take the next steps. I think one of the things is we will have to create a Oracle free tier or a Live Labs account. So if we just go there. You would get the free tier account, and you would have to enter the details around here, like the country or the territory to which you belong, probably the first and last name and the email address. And then finally, the terms of use. It will usually ask for a credit card it will not be billed for it. Primarily, it will be a free tier account. You'll have a credit for about $300, and you can use for about 30 days of credit that you will get out of it. So in this particular step, I think we would use some of the solutions out here. Like, we'll be quickly running an OCI data science instance. We'll be using Cloud Shell. We'll be using the OCI compute, and we'll be creating an autonomous JSON database. And these are some of the things that we will do as a part of the infrastructure provisioning, actually. So if you need any additional resources, you can as well go through. There is a GitHub repo. I'll probably add this in the chat window, so you can go there and probably build your own and try out some of these articles out here. And this would actually go through something similar out. When you want to go through the League of Legends optimizer game as such. So let's go to the next lab. So when we want to get started with this. So in order to get started, we will be creating a free tier account here. I mean, if most of you if you would have already created, you can log in your existing credentials. Or if you want to create a new one, you can actually go to cloud.oracle.com and primarily select the tenancy to which you belong. So since I've logged in, I'm just logging into it. Already I'm logged in here. But let me just see if I want to sign out and sign in back. So just sign out. So what happens here is you would have an identity domain that you would have already selected, and you want to log in back to it. So if you want to sign in back, so the tenancy that you would have selected is something you have to remember. For me, it is my own tenancy called Model Store, and I'm using that here for this particular exercise. So you just have to provide your username and password in order to log in back. So if you have not created it, primarily you would have to go through the cloud account and probably give the details and then sign up for it. And once you sign up, you would be asked to use a identity provider below. And the identity provider is something which is you would have selected or you would have known in an email that would have already been provided there. So once you enter those details, you'd be asked with a username and a password. And once you enter those details, you would be logged into the dashboard or the home button. So in this particular home, you would see a getting started in a dashboard. So if you have already familiar with this, there is a plethora of services that are already available here. And we'll be using most of the compute storage. We'll be creating a database, and as well as we'll be using analytics and AI. And within the analytics and AI, we'll be making use of data science services that are available here. So once you do this step, you should be able to log in and you should be able to see this particular step. So for the next lab, I'll just hand it over to Shane to take you through the infrastructure provisioning. Yeah, Shane, you can take it over now. Thanks.
Thank you, Shri. All right, I believe my screen is visible to all of you. So let's start with the infrastructure. So in this lab, we will be building the infrastructure that we are going to use for rest of our workshop. So just heads up, like this lab will be the repetition for those who have attended our first lab. So in this lab, the main component will be data science session and the notebooks, like which we are using to run the experiments on the newly generated data sets using notebooks. So just to give a brief overview of the infrastructure, like we will be creating compute instance, we will be creating autonomous JSON database, and we will be creating a data science notebooks. And this we are doing via Terraform script. So if you are not aware of the Terraform script, there is no need to worry because we have already everything set up. So we will be using a shell script to run the Terraform script. And just to give a brief overview of Terraform, it's an open source tool, like in which we tell like which resource we want to create. So we just tell the Terraform that this is the resource we want to create, and Terraform do rest of the work for us. So here, like we need to go to our Oracle Cloud account, and in the developers option, like on the top right, we need to open up the Cloud Shell. So once you click on the Cloud Shell, like it takes some time to connect, and then it will actually pop up. So it takes around 1 minute to open up, like it's do some configurations and all. So this is like a hands-on lab, like you can try right now. So like I will also try out some of the commands to set up the infrastructure and all. You can try along with me. And if you face any issues, you can just post the questions. All right, so this is connected and you can maximize it to view it properly and just do ILS. So like it won't be having anything right now because it's the fresh setup we are running. All right, so next step is like, so this is the Cloud Shell that we have opened up. And the next step, like we will be cloning our Git, from the Git League of Legends repository. So you can just copy the command here and run it in the shell. All right, it will do the copy. And when you do ls, so you can see League of Legends optimizer. Now, the next step is we will go into the development options here, like CD League of Legends optimizer and dev. Okay, so now I'm inside the development options here. Now, next step is like we will be copying the Terraform template is here. So we will be copying it and we will be filling the template based on the values. So to do that, like we need to open the code editor. So again, like we need to go to the developers tools here and open the code editor. So again, it will take some time like to connect. And once all the setup is ready, it will show up the list of directories. So just wait for like few seconds, it will open up. All right. So it has opened up. So I believe same is with you. So just click on the home directory here. And this is the League of Legends optimizer. And inside that, we have to go under this Terraform folder. Okay, this is the one. Okay. So now the next step is like we need to copy this Terraform template to our dev directory. So just copy this command and paste it. All right, it will copy it. So this is the file, Terraform dear boss. Okay. Now we need to fill up these values like config file profile. We will keep it as it is. It will be default. Then we will be like filling up region, tenancy OSIT, compartment OSIT, and SSH public key. All right. Now to get the tenancy information, like we can just run this command, echo OCI region. In the terminal, we can run this and we will get that this is the H11 region. Just copy paste it here. Okay. Now we need the tenancy OSIT. So for that, like we can run echo OCI tenancy. So this will give us the tenancy OSIT. So the output will be something like that. We will again copy paste it. Okay, so this is the tenancy OSIT and just copy it and add it here. All right. Next is compartment OSIT. So like there are two options available. So if you want to create all the resources in the root compartment, you can directly use the tenancy OSIT. So it will be the tenancy of the compartment. And if you want to create in some particular compartment, you can use some command. Let's say like I will be creating the resources in a networks compartment. So I will be using the OSIT of the networks compartment. So if you want to create it in a separate compartment other than root compartment, you can use following command. Yeah. So this is the command. You can just copy paste it and it replace the compartment name with the compartment in which you want to create the resource. So for example, here it is networks. Okay, so it will give me the OSIT of the networks compartment. So it is optional. You can create it anywhere. Okay, next is SSH public key. So we need to have like a pair of public key and a private key pair, and we need to generate it. And to generate it, we can use SSH keygen command to generate it. Okay, so can do it like this way. Okay, just we will keep all the options by default, like we don't be changing it. So it is saying that it will save it in the home directory and under .ssh and under IDRSA. Okay, so yeah, I will click no here. All right, so just to show you again, like if you are creating it for the first time, so it will actually ask like which like password and all, like you can enter the empty passphrase here and again same passphrase, and it will generate ID public key created like in this home directory, and this is the path for the public key, and private key is also in the same path. So the next step is to copy the public key. So you can do it using this command. Okay, so this is a public key here. All right. So we have the public key ready. So in our lab one, like we were actually using the APIs which were actually exposed by League of Legends game, like to download all the data and all. But for this lab, we won't be using these APIs, so we don't need this Roid game API key for this lab. All right. So once everything is ready, so we can actually save the file here. And yeah, all right. So we have the Terraform ready, and we are saying that we will be creating the infrastructure in H1 region under this tenancy and in this compartment. And these are the public key, like to connect with the instance and all. All right. So next is like, if you do the ls, like we have certain scripts available here. So this is a start.sh shell script, which we need to run. So it will call the Terraform script to create the infrastructure for us. Okay, so you can just do .start.sh and it will configure all the infrastructure for us. So again, like it will take some 5-6 minutes to set up everything. So once you run it, like you can actually wait for some time, and the output for this command will look something like this. Like it will be like Terraform in it, and it will do the initialization part, and then you can see the different resources are getting created. Like for example, like currently we are creating database. So here it will say that autonomous database is getting created. Then it will actually create the instance, which is nothing but the Linux based compute instance, which will be getting created. And after that, a notebook will be created, and we will actually see all the output here.
Shil, is it possible to zoom in a bit?
All right, I can try.
Is there anything on the Cloud Shell settings that you can try to adjust on the wheel that is on the top? Yeah, this looks good. Yeah.
Okay, so like I was saying that it has started creating the resources. So for example, like you can see here, like OCI database autonomous, it is trying to create. So similarly, like once it is completed, then it will try to create the compute instance, and then it will try to create the notebook session. So for this lab, like we will be requiring the notebook session to run the experiments. Also, if you want to see the status of the databases that you are creating, so you can directly check it from the console as well. So you can just go to the Oracle databases and create an autonomous database. So here also, like, you can check the status of it. Yeah, so this is the one which we are trying to provision. So it is available to use. All right, so next it is trying to create the notebook session, which will again take around 3-4 minutes to configure it completely. So till the time it creates the notebook session, I will quickly show like where exactly this resource resides. So you can minimize this particular shell. And under analytics and AI, like when you click on the menu on the top left and under analytics and AI, there is under machine learning, we have data science option. If you click on data science option, like it will list the following projects. So this is a project which was created as a part of this lab. And under this project, like we have the notebook session. So this is the League of Legends notebook session, which is in the creating state. Yeah, so this is the default configuration of this notebook session, which is like block storage is 100 GB and amount of memory, like this is again 15 GB and number of 4 CPUs are 1. And we can check the compute shape instance as well. It is running on VM standard 2.1. So once the script is completed and everything is created, so we can see the output something like that. Like it will say apply completed, and it will say like, for example, 11 resources added, 0 change, 0 destroyed. And then we can actually check the notebook session URL as well. So it will be something like that, HTTPS notebook and whatever the region in which it has created. And like the same way, we can also see the configuration of it as well, like shape and all. Sometimes it takes some extra time to provision the notebook. So it looks like it is the same case here. All right, so the notebook session is created. And as you can see, like this is the URL to access the notebook session. So there are two ways to connect with the notebook session. Like either you can copy paste this particular URL and open it in the new tab, or we can open up it from here directly. Like in the notebook session, like once we go inside the notebook, so there is a open button is available, so we can open it from here. So it has few final things to complete. So once it gets complete, so we can start the notebook session. All right, the Terraform script run is completed successfully, and these are the outputs. Like it has created some compute instance, autonomous JSON database, and the notebook session. So now we will be using this notebook session, and we will be configuring this notebook for our workshop. So, like I said, like there are two options to access this notebook session. You can directly copy paste this URL in another tab, and it will open up, or you can directly go it from the terminal, this console. So I will open it from the console itself. Okay, so it will ask like the session details. So I will just select this one. This is my default session. Okay, it will open up. Okay, so now it has opened up. Now, next thing is like we need to configure this for notebook session. So we need to open up the terminal. So like in the Explorer, you will find this terminal option here. Once you click it, it will open up the terminal. All right, so we need to clone this repository, League of Legends Optimizer repository here. So just copy paste this command. All right, so League of Legends Optimizer is here. Now next is like we need to install the Conda environment. So we will be installing the Conda environment here. Like you can just run this command, Conda install. So it installs multiple dependencies. So it takes some time to install this environment. All right, it is done. Okay, so next step is to install the dependencies. So we will be installing using this command. So it will take some more time to install all the requirements. All right. So the requirements installation is due, and next part is to download the data set. So we can download the data set from this particular data source. So this is the OSS data source from which we will be downloading the data set. Okay, so we just need to run this wget command in the terminal here. All right, so data set is downloaded. Now, next thing is we need to access the notebook that we will be using for our experiments and all. So like you can see on the left hand part, like we have this particular League of Legends optimizer folder available. So just click it. Okay, so under
Shane,
that,
can you zoom in again? It's pretty small actually.
sure. All right, so this is the parent folder that you might be seeing here on the left hand side, League of Legends optimizer. Once you click on the folder, like it will take you inside, and under that we have a notebooks folder is there. So once you click this directory, so like we have multiple notebook sessions available. So for this session, like we will be using this neural networks League of Legends notebook session. Yeah, so this is what it says. So I will now hand it over to Shri for the next lab. Thank you.
Sure. Let me know if you have reached the stage. I think this is where I think we would be going through the lab too, where we'll be understanding what a neural network is. So primarily, before we get into the neural network, we need to understand how our brain functions. It is primarily through the neurons, and similar to what a machine can have is called as an artificial neurals or artificial neurons. And in using these the neural network, it actually simulates like how a human think, how our human brains actually work. And we actually are trying to teach a computer on how it actually thinks and processes the data, similar to how the humans are actually going to perceive and look, hear, and see, actually. So we have a concept of artificial neurons called perceptrons. A perceptron is something similar to a neuron, and which would actually connect through our axons, actually, our through our neurons through axons, and then which we actually are able to configure it and then transmit the data bilaterally. So what happens here is there is a series of inputs that actually goes through, and we actually, for example, if you're seeing an image or anything, we are actually going to see it through our eyes, and then we are going to perceive it and recognize what is that object is. And similar to that, here we would have a series of inputs, and then we are actually going to produce an output out of it. So through these neural nets. So always a neural net has three components. Like one is the input layer, another is an output layer, and also there is something called as the hidden layer. So there are different type of neural networks. So if you're interested, there is something called as neural network zoo, or there are different architectures to it. So basically, it boils down to two types of neural networks. One is called as the feed-forward neural networks, and where the data is moving from input layer, and then finally there is an output layer. And then by the time the data reaches the output layer, the neural network would have completed its job. So and then the second one is called as the recurrent neural network, or the data doesn't stop at the output layer, rather than it actually, it has something called as a backward propagation, or it actually feeds the results back into the previous layer or the previously traversed layer. The reason being that, if there are errors that are, coming out of the traverse layer, that is actually feeded back into and reprocessed again. And then we are trying to reduce the number of errors that are coming up at every step. So we would do this iteratively, and this iteration is called as epochs. And there are specified number of cycles, like we would generally go through it. And there are different number of epochs that we would use, in this particular scenario. So if you just take an example of, different type of neural networks, there is feed forward and the recurrent, and then there is an element of back propagation or going backwards. So back propagation is nothing but a widely used neural algorithm within the neural net, and actually it has, it usually generally involves something called as the loss functions, like the loss with which we want to recompute back, and then finally we would feed this back into the previous layer and then use it forward. So there are the different components here is forward pass, backward pass, weight updates, an iterative process, and then there is also something called as activation function and loss functions. So we'll go through each of these in depth actually on here. So when we want to calculate, some of the important things, that the calculations are based on something called as the chain rule, which is a concept in the calculus. If it requires elementary calculus or elementary differential calculus that is involved in this. So most of the libraries today, that is like TensorFlow or PyTorch, or already have something called as automatic gradient calculator, which does these calculations for us. So we don't have to do any of these heavy lifting upon us actually. So here is an image that we would see in the terms of the neural network. This is the input layer that is starting, and this is the hidden layer. And then finally, there is an output layer on this actually. So this is nothing but a feed forward neural network, like the input features are being propagated, and then there is an output out of it at this particular step. So when we look at this is nothing but a recurrent neural network. So the recurrent neural network actually could be having, one or many layers, hidden layers here. Let's say this is an input layer, and there are, n number of, hidden layers, and then finally there is an output layer. So these output layer could be something like, it could be a classification or a regression or any of these. So these are the input layers. So for example, if you have xn number of input features, and these xn number of input features go through the hidden layers across here, and these hidden layers could be greater than one or many, and then finally there is an output that classifies that particular output is. So it could be a classification or it could be a target actually based on that. So let's take a simple example, and there is a very beautiful example, like something called as the open source playground. I'll just put it on the chat window here. It is actually on TensorFlow. You can see it on this particular one. So suppose you have a neural network which has, let's say, two features, X1 and X2. And then you have, let's say, hidden layers. There are 2 hidden layers, and you can play around with this. So you can increase the number of layers here, or you can decrease it here. And then primarily you can increase the number of neurons. The neurons are the fundamental units or cells here. And then there is this final output that is coming out of it. So in this particular output, what we are trying to do is we are trying to minimize the loss from the training data set and as well as from the test data set. So we can increase the ratio of training data set. For example, if I want to increase the split between training and test, let's say to 60 and 40 or 70 and 30, I can do that. So, or I can keep it like 50-50 across and then use it actually. And there is also, you can play around with the noise, introduction of noise, and as well as the batch size particular to this. So if you see, the epochs is nothing but the number of iterations that the neural network is going through. And it has something called as a learning rate and an activation function. We'll go through this particular thing. A learning rate is, let's quickly go through the learning rate. So typically when when a neural network actually has, it is trying to learn for every iteration. So the learning rate is actually determines the step at which it is trying to minimize the loss between the actual output versus what is trying to predict out of it. So in this particular scenario, we would actually use a learning rate depending on the type of, how fast or how slow you want to go. You want the algorithm to perceive actually. So, and there are something called as activation functions. And also the concept of activation functions is you would, so the activation functions is actually is something which is critical in the back propagation side. Where it actually affects the shape of the loss. I mean, basically how the loss is going to be appearing, and also depends on the gradient of the neural network. So there are different activation functions, something like sigmoid function, which you would have seen in the logistic regression. And finally, when we come to the neural networks, there is ReLU and TANH and so on actually. So the loss functions again is the it depends on the choice of back propagation. It actually is trying to measure the difference between the predicted output and the true output of it. And the common loss functions are like, it could be the mean squared error, cross entropy, or it could be something like a hinge loss. And it actually depends on the type of problem that we are trying to solve there. So here we are actually looking to solve a classification problem. And then if you see here, there are 2 features, there are 2 hidden layers, and there is 1 output out of it. So if you just run this, and it takes about maybe the loss function is trying to reduce it, the training loss and the test loss. And after a while, it doesn't, it is almost, the training loss is almost 0. And then the test loss is almost like 0.002. So this is something which is happening, but the number of iterations or the number of epochs that is increasing here, it doesn't affect anymore because it is trying to, the true output and the predicted output are almost the same here. So you can play around with this and try to learn different concepts across, and there is a lot of information around this, and this is a pretty much cool thing to play around, and you can simulate a lot of things out here. And also you can play with the type of data set you want. Like, you want something like a different data set, you can do that, like a clustering or any other types. You can play around with these things actually here. So I'm just taking one example and then trying to show some of the information out here. So when we look at it, the activation function is nothing but what should an activated neuron should be able to do it. I mean, should be able to perform. Typically, we have to choose the right activation functions here. And it could be like something like hyperbolic tangent, or it could be a sigmoid function. These are some of the common activation functions that is used. Something called as the leaky ReLU, or the or rectifier linear unit, etc. Some of these problems are used according to the problem that we are trying to solve, the business problem that you're trying to solve. So, and then when we spoke a bit about the loss optimizers. So the loss optimizers is nothing but we are trying to minimize the loss between the predicted and the true output. So we would use different type of functions here. There's a stochastic gradient descent, or it could be an RMS prop, or ADAM, or ADAGRAD, or ADA-delta. And these are also chosen based on the, it is nothing but we have to, there's a mix of trial and error that when we actually want to use these kind of activation function, or the loss functions out here, the loss optimizers here. So when we look at the amount of loss, generally a data scientist would try to apply a combination of these things, like using the different loss functions or the loss optimizers, or he could go through a different activation function altogether, and then try to see which is actually trying to give a very high predicted output or a metric that can actually minimize the loss out there, actually. So when we see it, generally it is compared, for every iteration or the number of epochs, the accuracy should increase and the loss should minimize, actually, as and when the iteration increases. So for example, if you see this particular curve, we are having a accuracy increase that is taking place as we go through the 200th or the 400th and so on. And after a while, it converges and it is almost saturated. It doesn't increase further beyond this. And similarly, when you see here, the loss functions are actually decreasing, and after a while, it doesn't, go beyond that. Actually, it is saturated here as well. So this is something which is actually determines how quickly the algorithm is able to adapt to the problem, the business problem that we are trying to solve. And higher the learning rate, the faster the loss will be. And then, but what happens is the downside of it is the inaccurate predictions or the inaccurate output. And generally there should be a balance between the number of iterations or the number of epochs. And then, also depends on what sort of learning rate you want to choose. You want to, it is like, imagine that you are on a steep hill and taking a faster step to reach the target, or if you are taking slower steps in order to reach this target. So we are trying to minimize the loss. And if you take a faster stride in order to reach the target, it might lead to inaccurate predictions. Or if you are taking a slower step by step, and then trying to reach that output or reach the target with minimum number of, or trying to reduce the loss as we go through it. So these are some of the fundamental concepts. I know that in the interest of time, we could not cover a lot more in depth, actually, but we'll just show some of these concepts, how it works in the next lab, actually. So let's go through the lab number 3. So we'll try to build a fast AI with a neural network with a fast AI. So this would take some more time. I might have to put a word of caution. So when we train the model, the epochs might take a lot of time, depending on the number of epochs we are using. In order to illustrate it, I'll just show you how it works or how much time it might take. So we'll take one step at a time. So this is actually based on the League of Legends datasets. I hope you've already downloaded the data. So when we did a wget, we got 2 datasets, that is the offline datasets.csv and the live client data.csv. So here we would be using these in this particular lab, actually. So let's look at, we'll be creating 2 models, like one for post-match data and the other one on, on the live data as such. So I just try to zoom in. Sorry, I think it's still the same. So I hope if you can open this particular one, not able to show this. We would generally see there is a match data, and this match data is actually showing, the relationship between the players and their statistics, like the champion stats, damage stats, position, etc., and some of these. And then it is actually showing a metric associated to that particular statistics, actually, on this. So if we take a level of information from any match, from any player, there's a lot of detail inside this particular data set. So we would see this like, something like a match ID. And for this match ID, we would be able to get the associated metrics from that particular player. So for example, if you see here, there's already like the match that has taken place and there is a game version that's happening. And then there is actually a metric that is associated here. Like, well, like it could be from that particular game, how many goals were earned, how many kills happened, how many assists were done, etc., on this. And then similarly, it could be another player, from that match where it is actually showing some of the statistics associated to it. So how do we identify? There is something called as a player unique identifier, and that gives this information out there. So what we want to do here is we want to use the win variable, or the it's nothing but a binary variable out there, and we want to use this to train our a neural network model, and then try to use this data in order to predict who will win if there is going to be a live game, or using the live client data, if we have a live game going on, who would win by how much percentage as such. So in this particular one, again, we would have some of these active player information, and then and some of these statistics associated to it. So let's go through it. Let's run this particular model. So what we'll do is we'll try to predict a winner from the data that we have already obtained so far. So in this particular one, let's go through the this particular notebook. So we'll go through the League of Legends, and inside here you will see the notebook. I've already opened it. This is the notebook you have to open. Neural Networks, League of Legends, the Iron Python notebook. And if you open this, you would see this particular offline data set. So generally, the offline data set is already downloaded from the wget function. These are the two data sets that we would have already downloaded. So let's run some of these. We would try to import the libraries first. So first, I will try to import the FastAI library. And from FastAI, we are going to use something called tabular dataset, or the tabular function within the FastAI. And then we are going to download the TensorFlow as well. So let's do that. So let's read this dataset. First, we will go through the offline dataset.csv. So let's run this. So if you run this, so to just show the, it's taking some time. So let's go through this. So it will generally show the goal down, total minions kill, win kills, and some of the metrics associated out here, right? I mean, that's what we got here. So let's say we want to see what are the columns inside it. So these are the columns that is in this particular data set. Goals on total minions kill, win kills, assists, etc., and the vision score, etc. And then there is also a player unique identifier, which is which is one of the important columns. So if we just do a df describe just to see what and all is there, it will show the details associated to it. And then what are the data types? We can just do a d types here. The data types will tell you, is it an integer or an object, or any of the type of information associated to this particular data set. So there are three non-numerical columns, which is the champion, which is in maybe a string. There is a player unique identifier, which could be another string. And then there is something called summoner name, which is actually the object as well. So what we will do is we will drop these three particular columns because we don't want to use this further. So we can use something called drop column, and using the player unique identifier and the summoner name. So from this particular data set. So once it is dropped, we would want to split the data. So what we are doing is we are trying to use 80% of the data for training and 20% for the testing purposes. So let's say what we do is we use something called as the random splitter. And this random splitter will be, we are going to specify at what percentage we want to use for validation and what percentage we want to use for training actually. So here I'm just giving the validation percentage to be 0.2 or 20%. And whereas 80% of the data, I'm going to use it for, for the training purposes. So I'm just using a seed function here to start with this particular splitting of the data actually. So let's say we want to split this. So the split uses the splitter function and then finally creates something called, it splits the data set out there. And then we want to use something called as the basic set of conditions that the splitter must pass. And then finally, we want to just test or at least see how it looks like. And what we do is we would actually use these items function, and then we create something called as the items from the range of arrays. And then finally, we would run this for the random seed consistency. And we would use this function in order to split this data with an array length of, let's say, for example, here I'm using around 30. And then finally, we could modify this and let's observe this particular data set. So when we want to test this, testing the splitting of the array, like you could see, these are the splitting ranges that we would get. So once we get this particular test split between the training and the test split, we would actually want to recode, or what I would say is, if we want to use a categorical variables like strings and numericals, we cannot directly use it within the neural network. So we will have to standardize it and probably convert it. And so in order to do that, we will actually have to see, we have these categorical names called champion, and as well as like, the continuous names like golden, minions, etc. So we want to see how it actually appears. So what we would do is, once we run this, we want to take, let's say, a sample, let's say a few data set. So what it would do is it would recode these, the gold earned or the minions, the win and the kills, etc. And this is what it looks like. So what we would do is we would use maybe like, we want to sample, let's say, for example, for the DAT of using the show batch function, we want to show only like maybe 10 records and see how it looks like. So if you want to use that, it gives you the champion name, the gold earned, the minions, the kills, etc. And then finally, it gives you the vision score. And then finally, the win is the predictor variable out here, which is actually in true and false. But we want to recode this true and false into numerical format. We will do that further. So first is we want to test the visualization. So what we would do is, if we use the np.where function, and then we would use a criteria. For example, I'm going to use a name called Samira, who's a champion. And then there should be a kills of more than 11. And then there should be a vision score of greater than 50. And then we want to find out whether there is any record or not. So we would find so many records that are with this particular name, actually. So now, once we got it, we would want to now use this particular data set in order to create a neural network learner. And we want to classify it, whether it is a win or whether it is whether it's a loss. So in this particular one, this will actually measure the accuracy of the performance. So what we will do is we'll use something called as a tabular learner from FastAI, and we will use the DLS that we have already created. So the DLS was created using the tabular data loaders here. So this is the data set that we are going to use here. And and we'll use the metrics for accuracy. And then before we start, we actually will use something called as optimal learning rate. So the optimal learning rate will tell us what is the suggested learning rate for this particular neural network to learn. So what we will do is we'll actually use something called as LR_find from the learn function, and it is a part of the tabular learner itself. So we'll use that. So it is going to calculate and tell us suggest an accuracy rate. So if you see here, it is around, the loss function will be more than 76%. I mean, like we're trying to see around 76. And then the learning rate is 10 to the power of -3. So 1 into 10 to the power of -3. So what we'll do is, in order to train this particular neural network, we will actually have to use around, a learning rate of 1 into 10 to the power of -3 with this particular function. And we'll use a learn.fit function in order to run this. So there are approximately 50 epochs to start with. I mean, we could take a 50 epochs, but in the interest of time, what happens is I'm just trying to use 5 here. If you want to really test it, try with 50 and see how the results are coming, and see whether the training and the validation loss are actually reducing or not. So that is the purpose which we have to see. And there are different methods here. some of the different methods is something called early stopping, or you can also use cross-validation or use a learning curve. So here we are using learning curve in order to determine it. So it actually plots the performance between the training and the validation sets. And then by examining those learning curves, we are able to determine whether the neural network is underfitting or overfitting, or actually has converged to a good solution or not. The last option is actually something called as a grid search, which also involves training a neural network with different number of epochs and primarily evaluating the performance, particularly on a validation set. So here, since we are using learning grid, I'm just going to simulate, how much it takes, because it takes about 50 iterations or 50 epochs to go through it. This is a time-consuming process. So if we just run this, so it's just like 5% of it. So this would take some time. So if you go through 50 epochs, so this is how the 50 epochs runs through from 0 to 49. So what is happening here? In every step, there is a training loss and a validation loss. So the training loss and validation loss should be in conformance, or at least in a ballpark figure. If you see significant differences between the two, I think you can stop the neural networks and change some of the parameters out there. So what is happening is, if you see here, the training loss started at 36.6%. It went up a bit, about 37.1. And then by the time it actually converges, it is, it is stopping at like around 50 iterations at 36.2%. And your validation loss is also around 35.3% out there. So what happens is the training loss and the validation loss is almost at the similar phases. And then your accuracy did not improve after a while. So if you see here, it is around 83.79% at the end of it. And when it started, it was actually around 83.6%. So it is not a significant difference, like it is just going around 83.79%. And every step is taking about 1 minute, like 50 seconds, or 1 minute 49 seconds. So that is what we are doing here as well. So this is like, this step will take some time in order to go through it. Yeah, so the first iteration, I think once it completes, it's going to, display this output. The epoch will be 0. It will produce the training loss. It will produce the validation loss, the accuracy for the first epoch, and the time duration it took in order to, in order to run this particular epoch actually. So if you see here, epoch was 0, the training loss was 37.0%, and the validation loss was 35.6%. Accuracy is around 83.62%, and it took about 2 minutes 42 seconds to generate this. So this is a time-consuming process. This is going to, when you want to train the machine learning model, this is where most of the data scientists would spend time, because of the trying to see the best algorithm and trying to see reduce the loss between the training and the validation across, and try to improve the accuracy in the meanwhile as well. So just going to take some time. So when we plot the loss, so generally the loss functions between the training and validation, we have something called as recorder.plot_loss. This is the function we would use to plot the observed loss. What you see in the blue line is actually the training loss, and as well as the orange one is in the validation loss that is happening out there. So this would display where you can see here that the training loss started somewhere more than 50%, and then it got converged to around 36 or 37% for the training data set. And then for the validation, it always started somewhere about more than 35%, and then it is always at this particular step. So, but whereas when you see the number of epochs or the iterations taking place, it's almost flat actually. There's not much of convergence that is happening out there. So this would take some time in order to run this. So let's wait for few more minutes to see if we get another epoch output. I think it's also because we are just using a very small compute shape. If you would use maybe a GPU or any other compute shapes, I think it will be much faster because this is like relatively a smaller problem. And if you use a bigger compute shape, let's say with the GPU instance, this will be much faster actually. So let this run. So let's move to the next step. So if you see here, the training loss is not that significant. Like, it's almost like 37.13. The validation is 35.56. Accuracy is almost the same. It has reduced a bit. So let it run for a while. So what happens is, if you just check the predictions, let's say after those 50 iterations, you would actually see, the win. You would see another column called win prediction out here. So if you just do the learn.show results, and it actually generates this data set with the other columns like champion, gold earned, etc. And then you had a column called win, and then the predicted win is the one which is actually predicted through the neural network here. So if you see here, it is trying to predict. If you see here, there is some amount of error or loss or difference between what is predicted as one or a win is actually a loss, as the actual one is lost, and so on. Like, if you see this is all win, actuals are win, but whereas if you see this is predicted as loss out there, and then here also, in this particular last row, that there is a the predicted results are wrong in this particular scenario. So let's say you want to make a class probability or a confidence with which you want to know, like just to predict the winning probability or the losing probability as such. So what is the winning probability? I think if you just see the predicted ratio, it is actually able to tell at 94.01% is the predicted probability that is going to predict whether this is a win or a loss. And then the losing probability is pretty much less. The losing probability is less than 5%. Approximately 0.059, which is actually around 5% across here. So the next step in this is probably you want to go and use the live data, the live client data, and then try to see how it works actually. So in order to do that, so we would explore this live client data set first. Let me just quickly run this one. Yeah, I just want to quickly show a few things how we can. Sorry. Okay. So let's explore this particular live client dataset. So the live client dataset has something called active player, and as well as they have the some of the metrics associated to it, like abilities, champion stats, and full runs, etc. And then they have their own metrics associated here in this one. So we have to predict the winner using the live dataset or live client dataset as well. So let's do one thing. I'm just going to probably in the interest of time, I'm just going to stop this particular one while training this because of it is going to take some more time. Let me just stop it. Okay, so let it stop. Might throw an error, that's fine. So what we'll do is we would first run the live client data here. So let's run this live client data. Should read this data set. So let's check the columns. So it has this something called winner column, which is, and then it has magic resist and all the metrics associated. So let's describe the data. So it has, so it gives you some basic statistics like count, mean, standard deviation, etc. For all the respective columns. There are 23 columns, and in 8 rows, we are just trying to see this data set. So now we want to find out the data types here. So let's find out what are the categorical variables, what are the type of data sets that are here. So if you see here, identifier is a string, and we want to remove that. Probably we want to drop this column called identifier, and we'll do the same thing here as well. So we'll drop some of the ones which we don't want to be used in the while developing this or using this to predict the winner actually. So what we'll do is we will actually create a column called label called winner and drop a few columns that we don't want. So once we do it, we want to see the new data set. So if you see here, there is a winner data set. We called it as a winner, and this is what the results out of it actually. So this is what it looks like for maybe 5 rows of data here. So now let's print the data types. And if you print the data types, all are integers out here. So again, we'll use a 80-20 split to split the data set between training and test. And then we have continuous variables and as well as the categorical variables. And also we would try to use tabular data loaders and in order to do this particular function. So once we do it, we show the batch. You use the dls.show underscore batch function. So we would see this magic resist and all the functions out here. Then we would use a tabular learner to learn the learning rate. So let's use the learn.lr underscore find function to find the learning rate out here. So, and just find out, there is something called as a summary function. If you type this learn.summary, it gives you what are the types of the architecture within the neural network model. So this is a tabular model. So first it goes through a batch normalization function. The output shape is 64/18, and the number of parameters used is around 36. We would use a linear ReLU activation function, and we would do a batch normalization of 1 dimension. And this would be like 64/1000 actually on this, and so on. Like we would go through another layer, which these are some of the the hidden layers that are underneath in the neural network. And finally, there is an output layer, finally, which we would get. It could be a linear function that we are using here, and then that is the output that we would actually get out of it. So what happens is it is actually telling us what are the type of optimizers used. The optimizer is an Adam optimizer, and then the loss function could be a flattened loss or a cross entropy loss that is used here. So this is the architecture that is used within the tabular model of this particular neural network. So if you use a fit function, again, I'm going to run this using the LR learn.fit function. And here there is we wanted to do about 150 iterations for the live client data. But in the interest of time, I'm just going to start running this around for maybe around 5 or 10, because it is going to take about quite a while to run this. So once we run this, I'm using a learning rate of 1 into 10 to the power of -5. And, this is based on the, it is actually suggesting between 10 to the power of -4 and -5, but I have chosen to be about 10 to the power of -5 here. You can choose 10 to the power of -4 as well, was the learning rate, and try out. So once we click on this learning rate and then run this function, you can see the training loss is very high. This is actually around 66%. The validation loss is also pretty high, which is not giving us a good amount of accuracy. And if you see, the accuracy is just around 59 or at least 60%. So when we plot the loss functions, it started more than about 72%, but it is slowly reduced to maybe about 66% across here by the time it ended with the 10 iterations. Similarly, when we go with the validation loss, it is also the same, not much of significant difference. But if you run it with about 150 iterations, you would see this would be the, sorry, not this, I think, with the live client data. It is not actually giving us that significant result. It is actually going around, the loss is around 62%, and the validation loss is 64%, and the accuracy is pretty not very high. I mean, 61.3%. So this is not like very high. So it is still, we can improvise further on this. So if you see the results would be at the last. So there is a winner and there is a predicted winner or a winner predict. So if you see here, there is a high amount of errors. That is, it is saying it is a loss, but there is a win. Similarly, we can see here as well, like it is saying as a loss or a fail, but whereas this is a win actually. So there is a scope to improvise this particular particular model, trying to improvise it further actually on this. So last but not the least is, we want to find out what are the most important, one is the prediction probability that we want to find out. And the prediction probability, when we run it, it is actually going to be about 62.3% is the win probability, and the losing probability is 37.6%, which is not a very high number, and we look at the prediction probabilities as such. So what we could do is, one is this data is a live data. So since this is a live data, we can actually use something like a time windowed information. So for example, if there is a, there's a dependency on the older data that is actually happening here. Let's say there is, it could be something like game 1 happened, game 2 happened, game 3 happened, and we are using this older data to predict the newer data here. So instead of that, if we move this like a sliding window, we don't want to keep the older data, and then probably we want to move this by one element forward. That might improve the particular results as well when we want to train and test this particular data set, or trying to give the win prediction. It will make the prediction better. So basically, a combination of few things, like we can try out with different data sets, or we want to use a recency of the data, like the most recent matches that are happening, collect that data and primarily train the machine learn the neural network model on that, so that the recent data gives you a better prediction than the older data as such. So in the next function, what we would do is we would actually go through, we want to find out the robustness to our model. We can actually use this to combine the win prediction probability. So once we run this, it would give a combined prediction probability of almost like 50%, actually. So in the last step, what we would have is, we want to export the model. We can actually use a learn.export function to export this particular model. And then we can use this, use the particularly, use this particular this model that we have actually used, the live client model, and then we can use to predict the, get the predictions out of it, actually. So that is something which we can do. So what we will do is, if we run this, the raw test predictions, it actually creates a tensor, and then gives you these prediction probabilities out of it, actually. So it contains all predictions and actually also the labels associated to it. And then we can use this to validate it. So the validation will give, this much accuracy across 61.5% and 64.4%. And finally, in order to test the predictions, we can use, a NumPy function to test the predictions. So what we would find is around, approximately 69.6% or 70% across on this. So this is what we would get. And then finally, what we would do in the end is, we would actually try to find out something called as the permutation importance. The permutation importance actually tells you which are the most important features or the important input feature that affects the winner probability or the winner prediction as such. So in order to do that, we would create a class called permutation importance, and then we use this, in order to find out the most important features within this particular data set. So in the end, if you calculate this permutation importance, these are some of the most important the features, the input features that affects the output. So that means like one of the important features is timestamp. That means that the recency of the data matters. There's also something called the max health, attack damage, armor, etc. around this. So these are some of the things that would, help us to determine what are the most important features that needs to be included, and maybe in the not so important features that can be dropped out of it. So with this, actually, we can keep a cutoff and then retrain our model to get a better prediction of this action. So with this, I would like to end this particular session. Thanks for this particular session. Sorry, any questions or any other questions or anything so far?
I think we've had a lot of questions today that have been answered. Thanks for the session. It was really interactive. I hope everybody enjoyed it. We have our final session next week in this series of this League of Legends, and we really look forward to seeing you there. We will send this recorded session out so you can run through it along with a link to the workshop. And again, we thank you for your time today. We look forward to seeing you next week. Thank you. Bye-bye.